So in this module, you're going to learn about reflections about the x and y axes. Those are two other transformations. Okay, so what does this mean and how do you do it? Okay, let's talk about item 1, reflections about the x-axis. So when you have a function, y equals f of x, and you multiply that function by -1, what that does to the graph is, pretend this is a parabola, my hand. What y equals negative f of x would do would be to reflect it about the horizontal x-axis. So it would look like now a horseshoe like that instead. That's kind of hard to see, so let me draw what I just said. So if you have y equals x squared, and you decide for some reason to multiply that by -1 in front, what that does to the graph is it flips it over about the x-axis. And that's what I wrote right here. When the right-hand side of a function, y equals f of x, is multiplied by -1, then the graph of the new function, y equals negative f of x, is the reflection of y equals f of x about the x-axis. Okay, you can also wonder what would it mean to reflect about the y-axis. Okay, so what it means is this, before we do it. It just means that if you have a graph like this, and you want to reflect it about, say, the y-axis, then the reflection would look like this. It would be reflected over here, and you'd get this new graph. Okay, so that's what it means to reflect about the y-axis. So let me read what is going on. Reflections about the y-axis. When you're given the graph of y equals f of x, okay, and you know what it looks like, if you were to plug in negative x into that function, what it will do is it will reflect it about the y-axis. Okay? By the way, if the graph is even, what that would do to it is nothing. It would look exactly the same. Because remember, even functions are symmetric with respect to the y-axis. Okay, let's now move though to example 1. Okay, so example 1 says this. If you have a function, y equals negative x cubed, you're supposed to graph it. So I wrote here, start with the basic function shown below and draw your graph on the same axes. So the basic function shown below is y equals x cubed without the negative. That's the cubic function in the library of functions. So now when I put a negative in front of that, what it's going to do is it's going to flip this about the x-axis, because that's rule number 1. So it's in front. So instead now it's going to look like this. It's going to be reflected up. So I'm going to draw it like this, and then like this pink over on the left gets reflected up. So this is a graph of y equals negative x cubed. It's a reflection about the x-axis. Okay, now let's go to item 2. Item 2 is illustrating the other reflection. Why do I say that? Because remember what it means to be the other reflection. The other reflection meaning about the y-axis. If you have y equals f of x and you do this to it, then that's a reflection about the y-axis. Okay, so that's exactly what happened. I had originally y equals x cubed, and then for some reason I decided, hey, I want to have it be negative x and then cubed. So I'm plugging negative x into the function. So what that'll do is it'll shift it over along the y-axis. So it'll look like this. That is reflected that way, and the lower lobe is reflected this way. So that's a graph of y equals parentheses negative x cubed. Okay? You'll notice, by the way, that this graph looks the same as the other graph. Okay? And that's interesting. You might want to think about why. It has to do with the fact that this graph is odd. Okay, let's talk now about example 3. Suppose that the point x equals 2, y equals 4 is on the graph of y equals f of x. Find a point on the graph of the given functions in parts A and B. So this is what you're asked to do. I want you to find the reflection of the graph y equals f of x about the x-axis. So when you reflect about the x-axis, what it's going to mean is the y values will become the opposite sign. So x stays the same, but the y values become the negative of what they were. Okay? Now let's read the directions for the reflection about the y-axis. Okay, and that's the y-axis. So now what you do is the following. It's the opposite. The point x equals 2, y equals 4, reflected about the y-axis, will now have the height the same, but the x will be the negative of what it was. Okay, so those are the two answers. A is here, and this one is B. Okay, let's go to example 4. And there's 5 examples total, by the way. Example 4 says this, it's multiple choice. Choose the function that matches the given graph. Okay, now this is one where it turns out you'll look at all your answer choices, and there's there's 2 transformations going on for each answer choice. So this is a little bit more complicated. We're combining ideas from the other videos. So let's see. This looks like the absolute value function, so we're not going to even think about choosing the squaring function. This is the absolute value function. It's just been messed with. Okay, first of all, it's been definitely flipped over. Okay, it has also been shifted to the left by 2 units. So it's got to be this. It's got to be y equals, let's take the absolute value function and shift it to the left. So remember what it means to shift to the left. It means you write x plus when you go to the left. And so what that would mean, if that were it would mean, okay, here's the absolute value, and then you move it over like that. That's what this graph would be. But it's been flipped over as well, so the answer has got to be this instead. You have to keep doing one more transformation, which we're going to do, and that one transformation is going to be this, y equals negative absolute value of x plus 2. Okay, so we hopefully have that answer choice, and we do. It's right here. Okay, it might be useful for you to look at the other answer choices just to see what they would do. Okay, let's go to the last one. Last one says this. We're given a function, and the function is this. It's h of x equals the square root of negative x, and then the minus 5 is on the outside. Okay, and it says what we're going to do is graph the function using the techniques, the 6 of them. Start with the graph of the basic function shown below. So that's the basic function, square root, and that's in the library of functions. So let's see what each of these things do. When you talk about this one only without the minus 5, this one being the square root with now a negative inside of that square root function, remember what that does is that is this format. And if you recall, that is a reflection about the y-axis. So what this would do is it would take the graph and reflect it about the y-axis. Okay, now when you do minus 5 to that, what that then does to it is it moves this blue graph down 5 units. So it's going to look like that. So we have to find that answer choice, and we have it. It's choice B. So that's it for this homework. This homework is a little longer than the other 2 transformation sections because at the end it combines all the 6 tools we learned about transformations. Okay? So good luck. If you have questions, you know how to get to us.